Hello dear students, welcome back to Ajar Physics. From this video, we are starting complete JEE syllabus video lectures on the same thing. So, I am going with motion in straight line chapter of first PUC. This is nothing but the first chapter in kinematics. Let us understand what is this kinematics first. Kinematics is a branch of physics which deals with motion of bodies or particles without concerning what causes the motion. To go further in kinematics, we must understand some basic terms of kinematics. One such basic and very important term is position of a body. See, position of a body sounds very simple, but this is a very what do you call important thing and playing a very key role in understanding motion of the body and to measure the motion as well. See, position is nothing but the location where the body is at present. This is called as position. Okay. Now, if somebody call you, okay, and you are in Mysore, and they will ask you where you are, you will say that you are in Mysore. See, this is not the proper way or correct method to specify your position or position of the body, because Mysore is a wide region of area and many body are in Mysore. Where exactly in Mysore need to specify properly. To specify the position of a body or position of yourself correctly, there must be one reference point. Say for example, in Mysore, there is an institute called an AJA Forum for Physics. AJA Forum for Physics is in Coimbatore Nagar and you are inside this AJA Physics Forum. Say for example, then what is your exact position? You will say that you are in Mysore, in Coimbatore Nagar, and particularly in AJA Forum for Physics. You are inside of that. Then actually you are specifying the position of yourself or position of the body exactly. So here to measure the position, you are taking a reference point. That reference point is nothing but this institute. Similarly, to specify where exactly you are, you will tell I'm in this room, the classroom for example, in front of this board at a distance of some 1 or 2 feet from the board. Here the reference point is the board itself. Okay, so therefore to measure the position there is always a need of a reference point. Without referring a point where without considering the reference point, you cannot measure the position of the body. In fact, by choosing different reference point, your position is going to change. As I told you already, I am in front of this green board, chalkboard, at a distance of 1 to 2 feet from the board. Okay, this is my position. Now I can consider one more reference point. Say for example, there is a door for this classroom. I am in this room and at a distance of towards the left and at a distance of some 10 feet from the main door. So my position is now changed to 10 feet because we are uh, changing the reference point. Reference point is now the door, okay, not the green board. So this is how to specify the position of a body. We are always in need of a reference point. But we cannot go on choosing the reference points as a door, a green board, or a building in a city, or an institute, or something like that. There is a standard method to choose a reference point and to measure the position of a body properly. Let us understand what is that. Anyway, to measure the position, as we have discussed, there is a need of reference point. In physics, the reference point is considered by considering the coordinate systems. So I will write Cartesian coordinate system. So Cartesian coordinate system, basically it is a set of three axes, three mutually perpendicular axes. Say for example, this is the origin of the coordinate system, and from the origin I will consider three mutually perpendicular directions. So this is going to be x-axis, this can be called as y-axis, and this is z-axis. There are three mutually perpendicular axes, out of which x and y are in the plane of the board and z-axis is coming out of the board. Okay. Now this can be used as a reference point. In physics and mathematics, this reference point, by considering this set of coordinates, is called as a frame of reference. We can also call it as frame of reference. Okay, so what is a frame of reference? Frame of reference is a set of coordinate axes, and along with a clock at the origin, there must be a clock also, because alone by using this frame of reference without the clock, you can measure the position of a body where exactly it is. I will tell you how to measure. But by using the clock at the origin, you can also, if the body in motion, you can also measure at what time, at what position the body was occupied. So that in motion, you can study position of body at different instant of time. Okay, so therefore this set of coordinate axes along with the clock at the origin is called as a frame of reference. Okay, so there are different types of frames of references and coordinate systems we have. This is a three-dimensional coordinate system. Okay, this can be used to measure the position. I will tell you how. Similarly, there is a two-dimensional reference frame or frame of reference where we can have only x and y axis, any two axes out of three. So this is going to be a plane. It's a two-dimensional reference frame, I say. Similarly, I will consider an origin, and along from the origin I will consider either any one of the direction out of the three. Say for example x-axis. This is also frame of reference. Okay, but it is a one-dimensional reference frame. Say here, this is the origin. The origin is what you call specified with the number 0. I mean, the position at the origin is said to be 0. And if you go along the x-axis further, you will meet 1 meter from the origin, 2 meters from the origin, 3 meters, 4 meters, and so on. You will go. If suppose the body is here, some person or some body is over here, you will say the body is on the x-axis at a distance of 2 meters from the origin. So here the position of the body is exactly specified where it is. Similarly, in 2D, if the body is not on the axis, maybe it is in a plane called xy plane. Say for example, the body is here. So position of the body is now specified by using two coordinates, not just x-axis or not just y-axis. Over here, you will draw a perpendicular to the x-axis. It is intersecting here. Maybe this point along the x-axis is at a distance of 3 meters from the origin. So its x position is now obtained. Similarly, from the body which is in the plane to the y-axis, you will draw a perpendicular or a projection. Over here, maybe you will get 3.5 meters from the origin but along the y-axis. So position of this body now can be written as 3 comma 3.5. See, this 3 is nothing but x position and 3.5 is nothing but the y position. So therefore, to specify the position of this body, we are using two coordinates. Now the body is said to be in a plane. Similarly, in 3 dimension also. Say for example, the body may be in a free space. It is not in a plane or not in one particular axis. The body is here. Its position, from this position in space, I will draw a perpendicular to the plane, xz plane or zx plane, something like this. Okay, I will write a bigger plane over here. So this is going to be a plane. See, this is a plane. This plane is nothing but zx plane, and if this is the position of the body in space or three-dimensional space, I will draw a perpendicular to this plane. Okay, so over here from this the point where this is nothing but a shadow of this body on this plane. So from this point to the z-axis I can draw perpendicular. From this same point to the x-axis I can also draw a perpendicular. So these positions will give the position of this body along the x-axis and along the z-axis. Similarly, where the body in a y-axis, from the body itself I will draw a perpendicular to the y-axis. Okay, so you will get, say for example, the body along the x-axis is at 5 meters, and along the z-axis body may be at 2 meters, and along the y-axis body may be at 3 meters. So position of this body is going to be 5 comma 3 comma 2. Okay, so this is X position, Y position and Z position of the body. So this is how in 1 dimension, 2 dimension and 3 dimension position of the body is going to be specified exactly by considering what you call this reference frame or the coordinate system. Okay, so here if I draw a straight line, say maybe for example from origin to the position, current position of the body, I will draw a straight line. This straight line from origin of the coordinate system to the position of the body where it is, this is called as position vector. So here the position vector is along the axis itself because the body is strictly on the axis. Similarly, here is the body in the plane. From the origin to this body, I will draw a straight line, and this straight line is called as position vector here in plane. Now this position vector is having two components. One component is along the x-axis, that is nothing but 3. You can write this as 3 meter along the x-axis as 3 I cap. Similarly, so this vector is having its component along the y-axis as well, that is nothing but 3.5 j cap. In the same way, in 3 dimension also, the body is said to be in space. So from origin to the body in space, I will draw a straight line. This is going to be the position vector. Now this position vector is having three components. Component along x-axis, component along y-axis, component along z-axis. Okay, so this is how we are going to specify position of a body by using this reference frames, coordinate reference frames in three different dimensions. 1 dimension, 2 dimension and 3 dimensional. How to find out the position? See, I'm telling specifically, position of a body is a vector quantity. It's not scalar because you're standing at the origin and you're looking at the object wherever it is. If suppose you are standing at the origin here and this is the body and you are looking at the body along the x-axis to specify its position. So this 2 meters from the origin gives us the magnitude of the position, and along the x-axis you are looking at, that gives the direction. So therefore position is a vector physical quantity. Similarly in 2 dimension or 3 dimension as well. Believe me, without the frame of reference, the concept of rest, motion and the fast, all these words will be having no meaning. So let us understand this sentence by using this example. Over here, assume that this is the surface of earth, the flat surface of earth, and there are two friends just standing beside each other and they are speaking. Now assume that this person is not moving anywhere with respect to the earth, and even this person is also moving not with respect to the earth. It means they are at rest. I can also say the situation in some other way. This person is at rest with respect to his friend, because when I say with respect to his friend, the origin of the coordinate system or origin of the frame of reference is fixed at his friends. That is what the meaning with respect to. Okay, so this is going to be the origin or the reference point, and with respect to this origin or the reference point, the distance or position of this friend is not changing. Then I can say that this person is at rest with respect to his friend. Okay, he is at rest. If suppose he started moving somewhat like this, he is said to be in motion with respect to his friend as well as with respect to the surface of earth as well. Now imagine that they both are at rest with respect to the frame of reference which is fixed on the earth itself. Say for example, our reference frame is the earth itself, and they are always at a constant distance from the reference point which is on the earth's surface itself. They both are at rest with respect to each other, and they both are at rest with respect to the earth itself. Okay, I hope you understood this concept. Now assume that I am changing my reference point to some other position. Now assume that one of these two, say for example this is person A and this is person B. Person B went to free space very far from the earth over here. Now with respect to the point which is fixed on the earth itself, the person A is said to be at rest. How can you say he is at rest with respect to this point, which is a reference point fixed on the earth itself? Because from the reference point on the earth itself to this person, the distance is always going to be constant. It is not changing. Means position is not changing. Okay. But if you fix your reference frame or the origin of the coordinate system over here, who is in free space, the whole earth is appears to be moving, because this is the reference point. At some point of time, from the reference point which is on free space to the earth, there was some distance, and earth is going to be changing its position, because when earth is going around the sun, uh, the distance from the reference points to this point, okay, the position of the earth is keep on changing, because the distance between the reference point and the earth is keep on changing. So therefore, earth is said to be moving, or this person who is on the earth is said to be moving as seen from the different reference point. Okay, so therefore, I am telling very clearly, whether the person is at rest or the person is in motion, it is all going to be relative. It all depends on which is the frame of reference that you are considered. So when you say the person is at rest, that is a wrong statement. Or when you say the person is in motion, that is also a wrong statement. So the correct way of telling whether the body is motion or at rest is by specifying which is the reference point. So therefore, very clearly, this person is at rest with respect to the earth itself. And this person who is on the earth is in motion with respect to the reference point, which is completely outside the earth. So as you change the frame of reference, there will be a change in the state of rest or in motion. Similarly, how fast the body is moving or how slowly the body is moving, it is also going to be relative. It all depends on different frames. When a body or a particle is performing motion, there are two types of bodies we can consider. One is, I will consider a cube-like body. So cube-like body, when you say this body will be having its dimensions. For example, length, breadth and height of this body. And of course, the body will be having certain mass. As well as the body or particle or something which is in motion can also be considered as a point mass or a simple particle. Even this is also having certain mass. See, this extended body can perform what you call the rotational motion as well as translatory motion. But this point mass can perform only translatory motion. There is no rotational motion is possible for this point body, point particles or point mass. Because in this chapter, we are restricting ourselves for rectilinear motion. We are considering the bodies as point masses, not as extended bodies. But we have always, in real life examples, we will be having a car or any vehicle or any finite sized body moving or performing rectilinear motion. But we can still consider an extended body as point masses when, suppose this body is traveled a certain distance, when it is moving from one point to another point with respect to a certain reference point. Assume that this is the distance covered by it. If suppose the distance covered by the body is very much bigger when compared to the dimensions, means the size of the body itself. Dimensions are nothing but sizes, length, breadth or height, whatever it is. In such situations, we can also consider this extended object as point masses. Okay, so what is rectilinear motion? Rectilinear motion is change in the position of the body with respect to the reference point in free space. That is called as rectilinear motion. But this body can also possess rotational motion. In rotational motion, body need not to change its position. It will be there only, but it is going to rotating about a particular axis. We will study that rotational motion later. In order to simplify the problems, okay, in order to study the rectilinear motion, I will consider, even though it is an extended body, as point mass. Okay, how to consider that, at what situations, and this is the situation for that. Now, as we go further, we have to understand two more important physical quantities in kinematics. So, distance and displacement. Let us understand the difference between them very clearly. And now, we are restricting ourselves to discuss motion of the body or a point mass only in one dimension. That means a body or point mass is moving only in one particular axis, not in a plane or in a free space. Now, assume that there is x-axis here. This is going to be the origin of the x-axis. This is positive x-axis and this is negative x-axis. At present, there is a person or a body at the origin. That means its position initially is x is equal to 0. Now assume that uh, this person moving from origin to this position, that means x is equal to 4 meters along the positive x-axis, and I will call this position is A and this position of the body is B. As an example, the body is coming back. Okay, he is assume that he is moving towards the origin again. So from B to some other position, say for example over here, I will call this as C. And again, we'll continue the motion. So body moving from C, position C, to some other position on the same x-axis, I will call this position is D. Over here, I will calculate the total distance covered in different space interval. Say for example, from A to B. From A to B, the distance covered is going to be 4 meters from the origin. See, so initially the body was at A, now the body is in B. So therefore the total distance covered is going to be 4 meter as we have seen in the diagram. Similarly, if the body is coming back to C from B, now A to B and then B to C. Now what is the total distance covered by the body? From here to here it is 4. From 4 to this position again it is going to be 2 more meters added. I mean the distance is going to be 4 meters plus 2 meters extra while it is coming to point C. So this is going to be 6 meters. So the distance covered by the body at the position C is going to be 6 meters. If the body continues to move and coming to this position -3 in the negative x-axis, what is the total distance covered? So here body goes from A to B and then from B to C and then from C to D. Okay, so this is going to be uh, 6 meters from A to C, as we have discussed already. 7, 8, 9, 10 and 11. So total 11 meter is the distance covered when the body reaches the position D in the x-axis. So basically the distance is a scalar physical quantity, because distance is not having any direction, because we are not concerning in which direction the body is moving, whether it is going along the positive x-axis or along the negative x-axis. That and all is not considered. What is distance means? Distance is the total path covered by the body. That's it. So that is what we have understood here by using this one dimensional motion. Now let us understand one more thing. What do you mean by displacement? Displacement is defined as it is the shortest distance from initial position to the final position. Here I am specifying it is the shortest distance. So therefore we must draw a straight line. From where to where we have to draw the straight line? From initial position to the final position only. Because we are specifying from where to where we have to draw the straight line, that means from initial position to the final position, displacement is going to be a vector quantity. Okay, so let us understand how to calculate the displacement by using the same simple one-dimensional motion. So from A to B, if you want to calculate the displacement, it is going to be 4 meters along the positive x-axis. So therefore I can write this. From A to B along the positive x-axis, how much is the displacement? That is nothing but 4 meters. This I cap is representing what you call the direction, which is along the positive x-axis. Next, when the body reaches the position C, how much is the displacement? Initial position is A, as I told you already, and final position is C now. So therefore, we have to draw a straight line from initial position to the final position. and this is going to be that straight line. I'm specifying this straight line with a arrow mark as well to represent the direction. That means we have drawn line from initial position to the final position. So from A to C, how much is the displacement is going to be only 2 I cap meters. Because wherever the body goes to reach the final position, it doesn't matter. We are only worrying about what was the initial position and what is the current position, means the final position. So we will simply draw a straight line from initial position to the final position, and we will take that as a vector. So that is what the displacement is. Similarly, if suppose the body while going to the position D, assume that the body is coming to the point A before going to the point point D itself. Now, moving from A to A itself after traveling somewhere on the x-axis, the displacement is going to be 0 meters. Because over here, if the body come to this position again on the x-axis, initial position and final positions are going to be same, and hence the displacement is going to be 0. Because there is no straight line we can draw from initial position to the final position. Now assume that the body while coming back, it will reach the position minus 3 meters in the same x-axis. Then how much is the displacement? From A to D, the displacement is going to be from 0 to this point, because this is the initial position and this is the final position irrespective of where the body went before reaching the point D. So I will draw a straight line from origin to this point. So it is, the direction is pointing towards the negative x-axis. Therefore, minus 3 I cap meter is the displacement. Okay. So what do you mean by displacement? Displacement is the shortest distance from initial position to the final position. That is what displacement is, which is going to be a vector physical quantity. But distance is not like that. It is a scalar physical quantity, which is a total path length covered by the body while it is moving. Okay. And most importantly, uh, the conclusion of this discussion is very simple. You know that if the body is going from A to B, distance covered and displacement having same magnitude. Okay. For simplicity, I will give different symbol for displacement and distance covered. I will call displacement with a symbol S and the distance covered with a symbol small d. So here in the first case, when the body is going from A to B, both the distance and the displacements are exactly equal. Now, when it is going from A to B and coming back to C, the distance covered by the body is 6 meters. But over here, while coming from A to B and back to C, the displacement is going to be only 2 meters. So therefore here in the second case, displacement is always less when compared to the distance covered by the body. And also you can see that in the third example, in the third case, where the body is going to the point B and coming back to the point A, displacement is going to be 0. Displacement can be equal to 0, but distance can never be equal to 0. It will be 8 meters. Distance is going to be 8 meters, but displacement is going to be 0. And similarly, in the last case, when the body reaches the position D, we will calculate the distance covered by the body as 11 meters. But over here, in case of displacement, it is going to be minus 3 meters only, which means distance can be negative, but distance is always going to be a positive physical quantity. Okay, so very simply, I can write it as displacement is always less than or equal to distance covered by the body. And distance can be always, it is always positive, but displacement can be negative, positive as well as 0. Now let's take some example for to solve and to understand the difference between distance and displacement in a more better way. Now there is an example. This is actually a body is going in a circular path, which will be going to be a two-dimensional motion for the body. But still, this is best example to understand the difference between distance and displacement. Assume that here is the body of particular mass going in the circle of radius 5 meters. Now assume that the body is going along this anti-clockwise direction and it reaches from A to B. So let us calculate in moving from A to B, how much is the distance covered by the body. Distance covered by the body is nothing but just 1 by 4th of the 2 pi r, where r is the radius. If you take 2 pi r, 2 pi r is nothing but the complete circumference. And when the body is going from A to B, this is nothing but just a quarter of the circle, full circle. So therefore, quarter means 1 by 4, which is nothing but the distance is going to be 2 pi r divided by 4. So as I said already, the radius is 5 meters. You can say that you can simplify this equation by doing this. 2 1s are 2, 2 2s are 2. So it is 5 multiplied by 5 divided by 2. So finally this can be equal to 2.5 times of pi, which is equal to 7.85 meters. So this is the distance covered by the body in moving from A to B. Okay. Now let us calculate the displacement happening from A to B. So from A to B, if you want to calculate the displacement, draw a straight line from initial position to the final position. If this is the final position, from the center of the circle, I will imagine a straight line. This is not displacement, but this is nothing but the radius, but in different direction. Now, from initial position to the final position, I will draw a straight line. Okay, so this straight line from A to B is representing the displacement. How to calculate the displacement? I will just use the Pythagoras theorem. See, this is 5 meter and this is also 5 meter. This is a right angle triangle. This is nothing but the 90 degree. And how to calculate this length of the line, which is nothing but distance, sorry, displacement. So I will write the displacement is nothing but this side, which can be calculated by using Pythagoras theorem. So according to the Pythagoras theorem, square of the displacement, I mean the square of this side, is going to be 5 square plus 5 square, means this side square plus this side square. I hope you know the Pythagoras theorem. Now displacement is going to be 2 times of 5 square under root. So which will be root 2 times of 5. 2 times of 5 can be approximately written as 7.07 meters. So which is very clear from this calculation. The distance covered by the body, which is 7.85 meter, is more than the displacement happening from A to B in the circle. So if you can imagine the same body continues to move from B to C, then how much is the distance covered by the body? It is nothing but half of the circumference. So 2 pi r divided by 2 you have to write. What is the displacement then? To get displacement, we will draw a straight line from A to C, and I will say this is nothing but the displacement, which is nothing but 10 meter, which is nothing but diameter of this circle, 5 plus 5. If the same body continues to move from C to A again, coming back to the same initial position, displacement will be 0. Right? Zero displacement, because initial position and final positions are exactly same. But how much is the distance covered? Distance covered will be one complete circumference, 2 pi r, which is nothing but 10 pi around. So therefore, let's go to second example to understand. This is the example of motion in 3 dimension, and we are calculating distance and displacement in this case. So here there are 3 axes, x-axis, y-axis and z-axis, and there is a body at the origin. Initially it is traveling in semicircular path and reaches 6 meters along the x-axis. After that it is traveling parallel to the z-axis and it reaches 4 meters along the z-axis in this plane. This is nothing but zx plane. And over here in the zx plane, after going parallel to the z-axis to a distance of 4 meters, and it is now going parallel to the y-axis, going upward, and it reaches around 3 meters along the y-axis. Now, how to calculate distance and displacement in this case? Let us calculate the distance first. Distance now it is equal to, so I will, distance is nothing but the total distance covered by the body. So here to calculate the total distance, the body now initially it is going in the semicircular path and reaching this position 6 meters along the x-axis. So what is the distance covered by the body over here? This is nothing but half of the circle of radius 3 meters, because from origin to this position, that is nothing but 6 meters. Because it is a semicircular path, radius is going to be half of this diameter. So from 0 to 6 meters is nothing but diameter, so that half of that is going to be a radius of the circle. So distance is going to be initially 2 pi into r is nothing but 3 divided by 2 we have to do, because just half of the circle, half of the circumference added with, now it is going parallel to the z-axis to a distance of 4 meters. So 4 meters along the z-axis, and it is going upward along the y-axis, and it traveled to a distance of 3 meters along the y-axis. Now, if you simplify this by putting the value of pi as 3.142 or 22 by 7, you will get distance covered by the body is going to be 16.42 meters. Okay, this is the distance covered by the body. I have taken all the path wherever the body have traveled from here to here. That is nothing but 16.42 meters. Now let us calculate displacement. Displacement, as I said already, from initial position to the final position, I will draw a straight line. This is initial and this is the final position. The final position is in free space. It is in 3 dimension. So therefore, now from here to this position, I will draw a straight line, and this is nothing but the displacement. How to calculate this displacement? I will call the displacement here is r. Now the displacement is having 3 coordinates, because this position is specified by 3 coordinates: x-axis, y-axis as well as z-axis. Along the x-axis, the body have traveled to 6 meters. I will call it a 6 into I cap. Along y-axis, the body is there at the position of 3 meters. So 3 j cap, plus along the z-axis, you know that its position is 4 meters. So 4 into k cap. So this is how we write displacement in 3 dimension or position vector. Okay, which is nothing but a straight line from initial position to the final position. So how much is the magnitude of displacement? If you want to calculate magnitude of the displacement, I will simply square all these components, 3 components, add them under square root. So therefore square root of 6 square plus 9 square, 3 square plus 4 square. So finally the magnitude of displacement you can get is 7.8 meters. See here also, distance covered is more when compared to the displacement happening in the problem. Now let's go to one more problem. Now let's come to the last example, and a very interesting one. So assume that there is a body going in circular path. While going in circular path, the body reaches from A to B. That means it is going in anti-clockwise direction. So radius is unknown, but it is given that the arc of the circle, the distance covered by the body is going to be 60 meters. And it subtend an angle at the center of curvature of this arc as 135 degrees. Then how to calculate displacement? That is what the question here. Displacement is how much? For that, let us calculate what is the angle, this 135 degree in radians first. So 135 degree is equal to 135 multiplied by 5 by 180 radians. So which can also be written as 3 divided by 4 pi radians. Okay, so this is the angle in radians converted from degrees. So 135 degree can be written as 3 by 4 pi times of radians. Okay, now after that, if this is the angle, you can calculate how much is the displacement now. Because how to calculate the displacement, which is very simple. From here to here, I will draw a straight line, because this is the initial position and this is the final position. From initial to final position, I have to draw a straight line. This gives us what you call uh, displacement. Now, from center of the circle to this displacement, to calculate the displacement, I'll draw a perpendicular. Okay, so maybe over here. So this perpendicular is intersecting over here, which is dividing the displacement into exactly two equal halves. So from A to M, half of the displacement. From M to B, there is another half of the displacement. Therefore, the total displacement is going to be 2 times of that AM, I can say, from A to M. So from A to M, 2 types of that is going to be the total displacement. Now let's calculate how much is the total displacement. So if this is total angle is 135 degree, that is nothing but angular displacement of the body, half of that is going to be 67.5 degree. This is going to be 67.5 degree. So let's calculate this AM by using this right angle triangle by applying sine theta over here. Sine 67.5 is going to be, how much is sine 67.5? That is nothing but opposite by hypotenuse. Opposite is AM divided by hypotenuse is nothing but the radius. We also have not calculated how much is the radius. Let us calculate the radius first by using this angle. We all know that plane angle, when an object is moving in the circular path, the plane angle can be written as arc divided by radius of the curvature. So here radius of the curvature is nothing but capital letter R, which is given over here. Arc is nothing but this arc, which is nothing but distance covered by the body while it is going. So therefore you can write this theta is equal to distance covered is 60 divided by radius is unknown to us. So radius is going to be 60 meters divided by this theta. In place of theta, I will use this 3 pi whole divided by 4. So you can calculate by simplifying this. The radius is comes out to be around 25.47 meters. This is going to be the value of radius. I hope you got to know how to calculate the radius in this example. Now I will use this radius value by taking this, so that AM is nothing but from here to here, which is nothing but half of the displacement, is going to be R times of sine 67.5. But I want displacement. Displacement is nothing but 2 times of that AM. So therefore, displacement is going to be 2R sine 67.5. Here R is radius of the circle, 2 is a constant, and we must know the value of this sine 67.5 using the Clark's table. I will write the value of them. So sine 67.5 is going to be 0.92, its value. So therefore we can calculate the displacement, which is nothing but 2 times of R. R is radius 25.47 multiplied by sine 67.5, which is 0.92. So you will get the displacement is around 46.86 meters. So here you see that once again displacement is going to be less than distance covered by the body. Distance is nothing but when the total path length it is covered, there is nothing but value of this arc of the circle 60 meters. So this is how distance and displacements are different from each other. I hope you understood the concepts, and thank you for watching. In the next video we will do the concepts like velocity, acceleration, and different graphs like position time graph, velocity time graph, acceleration time graph, and we will also solve the problem based on the same thing. Thank you.